All right, folks, we're going to review the first EOG review test you had, which I think was on Tuesday. So here we go. Looking at a chemical formula for methane, which is CH4, and a model of its structure, which is C with 4 hydrogens around it. The model of methane represents an ion? No. An ion has some kind of charge. This has no charge on it. Is this an atom? No, an atom's only one thing that doesn't have a name. Is this an isotope? An isotope is just an element with a different number of neutrons. There's no evidence or anything about neutrons on here at all. A molecule means more than one element bonded together. Do we have more than one element? Yes, we do. This would be the correct answer. It would also be called a compound. A compound is not a choice. Molecule is the best choice here. Which statement best describes the formation of rust? Rust, we all know, is iron that has been oxidized. Okay, rust forms from the chemical breakdown of old metal. That is not true. That sounds like a good answer, but that's not what happens. Rust results from physical mixing of iron with water. If it says physical, we know that rust is very different from what iron is, or any kind of metal here. Rust forms from physical change when wind blows against metal. That's ridiculous. The only answer that makes any sense here is that the rust results from a chemical reaction between iron and water. Chemical reaction. We got next question. Sodium sulfate and barium chloride react with each other to form sodium chloride and barium sulfate as shown. There we go. Which statement most accurately describes the mass of the reactants compared to the mass of the products? This is a lovely question with some beautiful pictures. All it's asking you is what is the conservation of mass? Okay, this is what we would say is a closed system happening in here. Nothing's able to escape. Nothing's getting in. Closed system. So law of conservation of mass tell us the products have a greater mass because the mass was created. Mass cannot be created or destroyed. Reactants have a greater mass because some of the mass is converted to heat. Again, if it's converted to heat, it's a closed system. Nothing's going to leave. The reactants have a greater mass because some matter was destroyed by the reaction. Again, this is a trick. Matter's not created up here. It's not destroyed. The only answer that fulfills the law of conservation of mass is the mass of the reactants is the same as the products. Which is the best evidence that a chemical change in matter has occurred? We learned from your baggie of science that either a color change happens or a temperature changes or a gas is produced or bubbles, which also pop and make a gas. So here, if a solid melts, that's like a piece of ice turning back into water, that's just a phase change, not a chemical change. Matter's destroyed, lie. Can't happen. Best answer here, gas is produced. Remember your beautiful baggie trying to burst almost. It got so full of gas. Or somebody in your classes did that. What best describes a solid that forms when two liquids combine in a chemical reaction? This is a basic just definition. Can't be a gas, that's silly. Gas is not a solid. Energy, that's not a solid. Precipitate forms when two liquids combine. What best represents a heterogeneous mixture? Hetero means different, so you should be able to see different pieces of stuff in this. Gas and gas, you're not going to be able to see a difference. Vegetable oil is homogeneous mixture. Sugar and water, if it's a solution, all you're going to look at, and it's going to look the same, consistent all the way through. Homogeneous mixture. Sand at the beach is made up of many different things. Many, many different things. And you can see the difference. Calcium carbonate is considered a compound because it's made up of two or more. Calcium here, carbon, 3 oxygens. These are 3 different elements. Makes sense. That's all it's asking. The compound is made up of 2 or more different elements. Two substances react and mass is recorded. The mass of the products does not equal the mass of the reactants, which is the best explanation for the difference in masses. This is telling us something happened here. Okay? Scale not being balanced. It's not making any sense. Substances are added after mass is recorded. That sounds pretty ridiculous. Some of the mixture spilled also, if it's a chemical reaction here, it's probably not going to have a problem. But what can happen, if it is an open system, a gas could have been produced and lost to the environment. This happens if you boil water and don't capture it all. It'll change the weight. Equation below. Suppose 11 grams of zinc reacts with 12 grams of hydrogen chloride, 12, to form 16 grams of zinc chloride, there you go, and an unknown amount of hydrogen gas. Based on the law of conservation of mass, how many grams of hydrogen gas will form? Law of conservation of mass tells us that matter is neither created nor destroyed, so the amount you start off with on the reactant side must equal the amount of mass in the product side. So if we have 11 zincs plus 12 hydrogen chloride right here, that makes 23. So that means the total of this side also has to be 23. So 16 plus what is going to give us 23? 16 plus 1 is going to give us 17. 16 plus 19 is going to give us 35. Also the big and. Only answer that fulfills law of conservation of mass, 7. The compound potassium sulfate, K2SO4, is composed of, if we look at our rules here, here's a subscript. This subscript is attached to the element before it. Which one of these says that we have 2 potassiums? 2 potassiums, is that possible? 1 molecule, no. 2 atoms of potassium, 2 molecules, no. You got rid of those things immediately. It's a great task always to do if you can. How many sulfurs do we see? There's only 1 sulfur. There's no number attached to it. If there's no number, we assume it's a 1. So 2 potassium we know is right. 4 sulfur, no. That can't be right. So the last one should tell us 2 potassiums, check. 1 atom of sulfur, check. 4 atoms of oxygen. That is correct. Done. A student kept the notebook during an investigation. Which recorded observation was most likely a physical change? Physical change is something that you can move back, change back to where you started. Okay? Solids form and 2 liquids were mixed together. No, that's something brand new made. Can't go back. 2 solutions are mixed and resulting thing felt hot. That's chemical change. Solution was heated for a minute until it was boiled. The color changed on this one. That's chemical. The only thing that makes any sense to be a physical change is it was heated for 2 minutes until it boiled. That means it went from a liquid to a gas, which is phase change, which is physical. If you collect that, you can turn it back into a liquid.